Hello everyone, welcome or welcome back to Coding Charms. In today's video, we are going to be solving the problem minimum fuel cost to report the capital. So in this problem, we are given with a tree which is connected, undirected and has no cycles. The tree represents the structured country network consisting of n cities and numbered. The cities are numbered from 0 to n-1 and there are exactly n-1 roads connecting those cities. Okay, the capital city is city 0. You are given a 2D integer array roads where road of I equal to ai comma bi denotes there exists a bidirectional road connecting cities ai and bi. Okay, so and there is a meeting for the representatives of each city. The meeting is in the capital city. There is a car in each city. You are given an integer seats that indicates the number of seats in each car. A representative can use the car in the city to travel or change the car and ride with another representative. This is the important point to note. A representative can use the car in their city to travel or change the car and ride with another representative. The cost of traveling between two cities is 1 liter of fuel. And what we have to do? We have to return the minimum number of liter of fuel to reach the capital city. So one road equal to 1 liter of fuel and we have to calculate the minimum number of liters of fuel to reach the capital city. Let us take a look at the examples. So in the first example, we are given with this graph. So to all the representatives should come to the capital city to attend the meeting. So there is a representative at each city. So representative should come from city 2 to city 0. So that will cost him 1 because the seats are 5. We have 5 seats in the car. So at most 5 representatives can sit in each car. So in this case at 0 we have at 2 we have a car and a representative. He can come in that car to 0 in the cost 1 liter. Okay, from 3 also the representative from 3 comes to 0 at the cost 1 and from 1 the representative of city 1 comes to 0 at the cost 1. So total cost is 1 plus 1 plus 1, 3. So we return 3 as the answer. And in the second example, we have this graph given to us. And now, in this case, let us start from here. We have a representative at 2. He comes to the city 3 with cost 1. And here the number of seats is given to us as 2. So at most 2 representatives can sit in that car, in each car. Okay, so here we have 1 representative sitting in the car and coming to the node 3. So here we have only 1 representative. At 3, we have 1 representative of city 3 and 1 representative of city 2. Both of them can sit in 2's car, right? So here we have 2 representatives and both of them can fit in the 2's car. So that car comes to 1. So we require only 1 liter of fuel to come to 1. 3 to 1. And now at 1, we will have how many representatives? 2 representatives coming from city 3 and 1 representative of city 1. Total, we have 3 representatives, but the number of seats in the car is 2. So we require 2 cars to get all the representatives from city 1 to 0. So here the cost will be 2 liters. And then from city 5, 1 representative can sit in his own car and come to city 0 in cost 1. And from 6 representative come to 4 in cost 1 in his own car. Then 4 can sit in the 6's car and both can travel to 0. The cost will be 1. So what will be the total cost? 1 plus 1, 2, 2 plus 2, 4, 4 plus 1, 5, 5 plus 1, 6 and 7. So the minimum cost is 7. So this is the problem. I hope you have understood the problem statement. So let us see how we can solve it. So what we have to calculate, we have to calculate minimum number of liters of fuel to reach the capital city. Greedily, we have to fit maximum number of representatives in car. So we can fit number of seats representatives in a car. So let us take this example only, the second example. So here we have 0 and 1 and 3 and 2 and number of seats is 2. Let's consider this simplified graph. And what's happening here? Here we have one representative and he is coming to 3 because we have seats equal to 2. So he can fit in his own car and he is coming to 3 in the cost 1. And from 3, at 3 we have 2 representatives. Both of them can fit in one car. So the cost of getting from 3 to 1 is 1. And at 1, we have 2 representatives coming from 3 and 1 representative at 2. So total number of representatives is 3. And since 3 cannot fit in one car, we require 2 cars. So how can we calculate the number of cars required at a city? We can do cars equal to number of persons at that city divided by number of seats. So we can take seal value and we can calculate the number of cars. So here in this case 3 by 2 we take seal. So this will be seal of 1.5. Seal of 1.5 will be 2. So we require 2 cars. So here 2. So the total cost will be 2 plus 1 plus 1. The total cost will be 4 to get to city 0. What we can apply? So we have two graph traversals, DFS and DFS. Since we are not asked any shortest path or anything, so we can simply apply DFS because it is easy to apply. So we can apply DFS, and while returning the DFS call, we can return number of persons from this city to coming to the next city. We can return the number of persons in the DFS call, and to compute the total cost, we can have any global variable answer or result, and we can add these values while performing the DFS calls, 2 plus 1 plus 1, and we can finally return after completing all the DFS calls, we can return this answer value. So let us code it up. When we code, the things will get more clear. So firstly, we can calculate number of nodes in the graph. So number of nodes in the graph we can calculate using, we have exactly n minus 1 roads. So if we can calculate roads size and we can add plus 1 to get the number of nodes. And now what we can do, here we are given with the edges, roads. So from that we can build the graph. So let's build a graph, vector of int roads, and not roads, the graph. So graph and n. And now we can iterate over the roads, auto roads, roads, and we have EA equal to roads, road of 0, comma, B equal to road of 1, and this is a bidirectional tree. So we have A to B. We have to add A to B and B to A to our graph. So let's do that. G of A dot push back, G of A dot push back B, and then G of B dot push back A, right? Now we have built the graph. Next we have to call DFS. So firstly we pass the current node we are at, and we have to also pass the parent node because this is an unidirectional graph. We have to avoid loops. We have to coming. So if you are at you came from U to V, and this is a bidirectional graph. You came to U to V, and you shouldn't go. You don't want to go back from V to U, right? Then that would be a circle. You will loop here only. So to avoid that condition, we have to pass the parent. Let's say -1 as the parent, and we have to pass the graph. We have to also pass the seats, graph and seats. And finally, we should also keep track of a global variable answer. So let's keep track of it. We have to return a long value. So this answer should be long as well. And finally, what we do, we return the answer. So let's implement the DFS, the main function. So DFS returns the number of people, right? So it is an integer, and DFS int current node and int parent and graph vector of int graph This we can pass this by reference, and then we have number of seats, and initially at node we have one person, right? So initially the person is 1, and now what we do, we iterate over the neighbors of node, and if we have to check this condition, right? If neighbor is equal to parent, then we don't want to, but we just continue. And if it's not, we calculate the persons coming to this city, persons plus equal to DFS of neighbor comma, the parent will be the current node, and we pass the graph, we pass the seats as well. And now after computing all the persons, what is this? Okay. After computing all the persons coming to this, what we do? We update the answer. We update the answer. We don't update the answer when we are at 0, because our 0 is our destination, right? We don't have to go anywhere. If the current node is not equal to 0, then we update the answer. Answer plus equal to, so plus equal to, what will be the answer? C loss double of number of persons divided by number of seats. So this will give us the number of cars. We update the answer with the number of cars, and finally what we return here, we return number of persons. So we return persons. This looks good to me. Let us run the code. Here, this is, let's see it as G over here. Let's run the code. Passed all the sample test cases. Let us submit it. So it passed all the test cases. What will be the time complexity of this approach? So the time complexity approach would be the normal DFS time complexity, which is O of n plus n only. In this case, O of n plus n, because we have the edges equal to n and the nodes equal to n. So the time complexity would be O of n, and the space complexity would be O of n as well. This recursive call stack, and the graph, here we are taking the graph as well. So time complexity and space complexity will be O of n. I hope you have understood today's solution. It's a DFS, classic DFS, and we are just adding another condition over here. Apart of that, everything is similar. And if you did understand today's solution, make sure you hit that like button and subscribe to Coding Charms for more daily videos. Till my next video, keep practicing. Take care. Bye-bye.